Hello friends, today's question, we have two masses m1 and m2 are suspended together by a massless spring or spring constant k. When the masses are in equilibrium, m1 is removed without disturbing the system. Find the angular frequency and amplitude of oscillation m2. So we have this spring constant given as 2, and there are two masses m2 and m1. And when the equilibrium is reached, the mass m1 is removed, and we have to find out what will be the angular, you can say, frequency as well as amplitude of oscillation for m2. So we can say redraw this figure, and let us suppose this is our spring, and here there are no mass connected to it. Then we can draw that there are two masses connected to it. So this is our m2 and this is our m1. Now when this m1 is removed, the spring is going to move towards, you can say, oscillate about the mean position, and we have to find out what will be that mean position. So specifically with respect to when there is no mass and when there are two masses, let us suppose this total extension is called as x old. Okay, and when m1 is removed, the spring, let us suppose it is now extended up till this position. So we have, this is our m2, and we call this as x new. So we have two positions, one is x old and another one is x new, and we have to find out what will be the amplitude of the oscillation when m2 is removed. So let us discuss first case when m1 and m2 are together. So we say mass m1 and m2 are suspended together therefore at equilibrium the total stretch that will be produced in the spring will be combined weight of m1 and m2. Therefore we can say that at equilibrium the spring is stretched due to combined weight of m1 plus m2, and the initial displacement for m1 and m2, let us suppose it is called as x old. You can write that the initial displacement for m1 plus m2 is called as x old. So it means at equilibrium the restoring force that will be acting on the spring because of these two masses will be equal to K multiplied by the extension, that is x old, and that will be equal to m1 plus m2 multiplied by G. Okay. In the downward direction, we are going to have m1 plus m2 multiplied by G, and in the upward direction we are going to have a force, let us suppose that is called as Fs, and in this case, or rather we can say, let us call it F old, and F old will be equal to spring constant K multiplied by x old. So we can write at equilibrium K multiplied by x old will be equal to m1 plus m2 multiplied by G. Now we come to the second condition, that is when this mass m1 is removed. Second condition, when mass m1 is removed. So because m1 is removed, now the spring is going to reach a new equilibrium position, and that equilibrium position will be dependent upon the amount of displacement that will be produced in the spring, and the amount of displacement produced in the spring will be now because of only of the m2. So you can say the spring reaches a new equilibrium position as the spring is stretched only due to mass m2. Mass m2, and we say that this new displacement because of mass m2 is called as x nu. Okay? So yeah, this displacement is called as a x nu. New displacement for mass m2, let us suppose it is called as x nu. So now in the downward direction we are going to have only one force, that will be m2g, and in the upward direction we are going to have only one force, let us call that as f nu. Now f nu will be equal to k multiplied by x nu. Therefore at equilibrium k multiplied by x nu is equal to m2 multiplied by g. Now we have to find out what will be the amplitude of the oscillations. What will be our A? Amplitude of oscillations. So as soon as m1 is removed, the spring is going to oscillate about its initial position. Okay. So therefore the amplitude of oscillation will be equal to x old minus x nu. Okay. You can say when M1 is removed, the spring starts to oscillate about its initial equilibrium position. About its initial equilibrium position. And if it's going to oscillate about its initial equilibrium position, then we can say the amplitude of oscillation will be the difference between the old equilibrium position and the new equilibrium position. Therefore, we can say that the amplitude of oscillation will be difference between old equilibrium position, old and new equilibrium position. So we can write that our A will be equal to x old minus x new. So we substitute the value, we get this as x old is our m1 plus m2 divided by k, m1 plus m2 k multiplied by g, and new is our m2 divided by k multiplied by g. So if we solve it, we are going to get A will be equal to m1 upon k multiplied by g. So this is the value of amplitude, and angular frequency we are also supposed to find out. You can see angular frequency it will be equal to omega, and that will equal to square root of k divided by m2. So this completes the question. Thank you.